Hello, my name is Yves-Michel Leporcher and I am blockchain specialist at Renault Group. During my career, I had the opportunity of working in different areas like finance or automotive industry. I wrote one book about risk management, and since 2015, I focused on blockchain technology, wrote 2 books on it, developed my own protocol, and joined Renault as blockchain and data specialist in 2018.
Hello, my name is Odile Panciatici and I'm blockchain vice president at Group Renault. I spent most of my career designing innovative cars, and during the last 5 years, I worked on digital transformation. I would like to share with you my understanding of blockchain technology, not as a geek, but as a mechanical business engineer, the interest of this technology and why I think it will support a future industrial evolution. Then Yves-Michel will share the technology view, and we will focus on the first collaborative blockchain project we tested in our Douai plant. We have a big evolution of our society. Our citizens are more and more demanding, and when they are not happy, they are pushed by lawyers to intend class action. Our society is becoming more reactive, more connected, more smart, with a great need of authenticity. In automotive industry, the competition landscape is changing, with newcomers not belonging to industry and new collaboration for offering mobility service and not only providing cars. At the same time, the level of technology is increasing fast, with connected and autonomous cars and connection with Internet of Things. And the severity of regulation imposed by politics and authorities is increasing fast, answering to citizens' demand. Next. Making cars and delivering mobility services is involving a lot of function: engineering, manufacturing, logistics, sales, after sales, purchasing, quality, and so on. Within OEM, suppliers, dealers, company, we have a lot of functions working in silo. Blockchain will change the way we work, allowing us to make links through all the functions of all the company working together and bringing more speed and reactivity in the exchanges and processes. Within our industry, we have 4 main ecosystems: production with suppliers for making cars and developing mobility services, dealers through the world for selling cars and services, clients for relationship of sales and after sales of car and services, and more mobility partner for defining new ways of mobility. All these ecosystems are linked and interact together. All these ecosystems are made of deep connection chains. Blockchain technology is not needed generally within one company. A lot of existing digital technologies are sufficient to make the job. But when you work with external companies, when you need to certify information in a trustworthy mode without a third-party certification, or when you have complex processes with several actors, or when you need time or money to reconcile data, blockchain is now the ideal solution. The blockchain may be considered as a mesh above the processes and the databases of all the members involved in the network. Today, when we work in an ecosystem, each company has its own process, and to exchange data and information, we define a transformation matrix between the respective processes, and we spend more time in defining the means of exchanging than on working on the data itself. With blockchain, each data owner loads his data in the blockchain. We have a lean ecosystem process, focusing on data and data model instead of exchange format. Due to the security and mode of data exchange, the blockchain technology is not very intrusive and may be implemented in a reactive mode. I would like to share now the 3 steps we see in implementation of blockchain and why we think that it helps us in a future evolution. The first step is the change of the network. Let's take an example of production ecosystem of an OEM with its supplier. We work now in a star network where the OEM is in the center of the star and all the information exchanged through the ecosystem are passing through the center of the star. With blockchain, we flatten the network and we can allow by governance direct data exchanges from one supplier to another, remaining compliant, of course, with antitrust law. The second step is the automatic check and alert of data, thanks to the smart contract. Smart contract is neither smart nor a contract, but only the execution of an algorithm. And why it is so important in our industry? Because we have through the ecosystem a lot of information and data protected by confidentiality or intellectual property. Thanks to blockchain technology, the data must be put in the ledger in a encrypted protected mode. Those data are only accessible by the owner, but you can execute a smart contract on it and provide real-time information to the network. For example, if you want today to deliver real-time conformity information about a process protected by intellectual property, you can do it in an easy, secured way. With blockchain, you can. We can talk also about softwares where codes are often protected by intellectual property. The third and most interesting step, but we need the two first ones for reaching this one, is to create a collective intelligence. Today, we have a very complex technologies. For connected and autonomous car, we deal with more than 200 connected softwares. We really need real-time sharing at ecosystem level to make more evolution towards future demands. The ecosystem collective intelligence will allow each member to be more reactive and to go to the several steps of prevention, prediction, prescription. This is a key asset of blockchain technology because it is done in a very secure mode, certifying data owning. Let's sum up the value brought by blockchain. First, you get performance, increasing efficiency within an ecosystem with automatic and real-time access to data and automatic checking and alerting of data. The interesting added value is to create digital continuity with the smaller actors of the chain that may not have an information system on their own and may access to a powerful blockchain system at low cost. Then you get reactivity in implementation of blockchain, as it is not very intrusive in the information system of each company, and in usage because it facilitates real-time exchanges. And reactivity also allows to increase customer satisfaction. You have certification, authentication, and anti-fraud by design. The important thing is the certification of data owning. Last but not least, the opening of new opportunities with new data generation, new business opportunities, and business model transformation. But at the center of the value, you find trust within the ecosystem and outside of it. You change from a customer-supplier relationship to a partner relationship, and this is very powerful in the world evolution. In difficult times, the collaboration is the only way to continue progress and innovation. Blockchain projects are collaborative projects, and it means also shared expenses and shared risk. Now, Yves-Michel, floor is yours for technical aspects.
I will now recap how a blockchain transaction usually works. Consider Bob on the top left and Alice on the bottom right. We are on a special network, hence we need a special mechanism. First, Bob wants to send a certified information to Alice, and he wants also to be certain that she did receive it and no one has intercepted it or changed the content. The information is prepared in a package, the second icon you can see, and it includes all the information a bit like in a mail. Second, it is sent to a network of machines using an algorithm called a consensus. There exist several types of algorithm, each having its particularity, yet only one should exist for a given network or blockchain. I will explain more in details in a few slides. After some time, the block is validated and added to the chain of previous blocks, hence blockchain. Finally, the message is received by Alice. Both have the certainty that the message was well emitted and received with unmodified content. We have more than 1,000 technologies, yet we can classify them in three main categories: public, consortium, and private. On the left, public blockchains are opened without any control on the participants. Anyone can use it, such as Bitcoin or Ethereum. They tend to consume a lot of energy, again Bitcoin, but more recent technologies have significantly reduced their environmental impact. In the middle, consortium blockchains. They require an access permission of participants, yet they allow companies with different interests to exchange data in a secured way. While very promising, especially for the heavy industries, one has to pay careful attention for interoperability between such blockchains in the future. One of the main obstacles is to succeed the implementation of the governance. A blockchain project must be a win-win project. The value must be found by each party, and this kind of business model is definitely not as easy to find. On the right, we can observe private blockchains, which means a company takes a very sophisticated way to build trust between each department of the company. This situation has proved so far little benefits in production environment. By experience, we have tried several technologies, and public blockchains have yet to be improved to allow a corporate-grade solution. We have evaluated a number of them, three of which are of high interest for the industry. First, Hyperledger Fabric, which is designed for industrial and supply chain aspects. Open source and free to use, it is highly customizable and evolutive. One of the fastest consortium blockchains to date, with between 700 and 3,000 transactions per second. As a vector of comparison, it is an average rate of transaction on Visa networks. The programming languages are rather common, Java and JavaScript. Nevertheless, I strongly recommend using Go for coding smart contracts, which apply the business logic on an algorithm side. The second one is called Corda. It is highly secured and allows a high level of confidentiality. At first, it was designed for financial sectors. It may have several use cases in the industry of services also. The performance is comparable to Hyperledger. For instance, about 70% of Italian banks are currently connected to Corda network to manage certain type of transactions. The programming languages is quite common too, with Java and Kotlin, a very similar language to Java. Finally, IOTA is a technology designed for IoT transactions. The performance is as high in consortium blockchain, but as a specialist, you should pay close attention because the public version of this technology will not go beyond 300 transactions per second. And while it is slightly more secured, you have to be extremely careful. Once again, Java and JavaScript are well-known languages which are applied to code with IoT. As mentioned earlier, the consensus is something very important. It is a mathematical algorithm which aims at validating transactions on a blockchain network. Innovation never stops, and there exist more than 30 of them. The validation actually considers two aspects, namely, the message was indeed transmitted, which means that no technical failure occurred. But it also means that the message has not been corrupted or modified by someone or something between the emitter and the receiver. The three main consensus are proof of work, proof of stake, and raft. The proof of work requires machines called miners to find a solution to the mathematical problem. A bit like finding the solution to x when 6 equals to x. Of course, finding the solution requires such a computation power so that you can state the effort is so large it can only be true. Next, we have the proof of stake. It requires a much lighter computational power. A few machines may validate that they have, the few machines that can validate have a very special status. The idea behind it is that the owner of the machine would have too much to lose if a transaction were not correct. In summary, I am right, else I lose it all. The third one is Raft, which is publicized as a variant of practical Byzantine fault-tolerant mechanism, or PBFT for the technical ones. In practice, while it prevents technical failure, it only asks 2/3 of participants of the network to validate the transaction. To sum up, it is true because most people believe it is true. The blockchain projects are by default open to the outer world. Security is key. A Deloitte study in 2018 suggests that top managers believe it is more secured than more conventional digital approach, with a whopping 84% positive appreciation. Indeed, one of the first aspects as a technician that you put in place when setting up the network is to configure the security configuration files. Out of the main security topics, network and access rights are basically conventional. The audit of the consensus as well as the code are a bit different, however. Public blockchain code have a dramatic consequence because anyone can reuse a potentially weak code with security failures. Therefore, be wise when you choose your code and your platform. Consensus blockchain code, however, have a much more limited impact. They also require the specialist to craft it in a different way while using the language they know. To sum up, the technology is secured by design and requires additional skills to monitor and manage properly. I would like to underline a key question about skills and competencies. The chart on the left shows that in 2018, several countries have invested and internalized blockchain skills. China seems to be in the top investors. Yet, companies in other Western countries have already engaged in similar behaviors. The US seems to have a lower stake. Two possibilities applies. The audited sample of companies is biased because actually the US did invest billions, especially in the defense department. The second possibility is that it goes against some GAFA's interest because the data actually is hidden from them in a separate network. 2019 has seen no change in the demand. For instance, a recruitment site well known for identifying current needs only has witnessed a significant surge in blockchain specialists by more than 500% increase, far beyond hyped professions such as AI or big data skills. It seems obvious that we shall witness a bottleneck on blockchain competencies. This will have an important impact on the make or buy choice. And I will now leave the ground to Odile that will present the project led by Renault as advertised last week in the news.
Let's focus now on our first collaborative project. You may have seen a press release a few days ago. Exceed, Extended Compliance End-to-End Distributed, is a digital project resulting from Group Renault's collaboration with major players in the automotive industry. It is based on Hyperledger Fabric, blockchain technology, and it is designed to track and certify the regulatory compliance of vehicle components and subcomponents. Why this project? The new regulation requesting more and more certification and reactivity. The value will be operational excellence and reactivity in answering to authorities, but also to our customers that are more and more demanding. You can see on the scheme how efficient this collaborative mode can be. Testing at Renault's Douai plant was used to consolidate the value and performance that blockchain technology delivers for the automotive industry, with over 1 million documents archived and a speed of 500 transactions per second. As a conclusion, I would like to come back to the VUCA world where we live. The last months show how fragile we are and how agile and smart we must be to survive. To face these events, the collaboration is a must. But for that collaboration, we need trust. And obviously, blockchain technology is an asset to help us to face the VUCA world. But more than the technology, we need to change our mindset. Working in a collaborative mode is not that easy, particularly with big old companies having their own strong culture. This is a key for getting ecosystem agility. Our first experience gives us confidence to succeed in this tricky task. Thank you for listening.